Today, we'll explore the cutting-edge techniques of generating synthetic data using LangChain and OpenAI models. Synthetic data is becoming increasingly important due to data scarcity and privacy concerns, offering practical solutions for various use cases. Understanding synthetic data. Synthetic data refers to artificially generated data that mimics real data distributions. It's crucial in scenarios where obtaining real data is challenging, either due to privacy regulations or limited availability. Traditional methods vs. generative AI models. Traditional methods such as statistical modeling or deep learning often require large amounts of real data. In contrast, generative AI models like GAN's generative adversarial networks and these variational autoencoders can efficiently produce synthetic data that preserves key statistical properties. Use cases of synthetic data. Synthetic data offers a range of benefits and applications. Privacy and security. Protects sensitive data while enabling analysis and model training. Data augmentation enriches training datasets, improving model performance. Cost effectiveness reduces reliance on expensive real data acquisition. Regulatory compliance safeguards against data privacy regulations. Generating synthetic data from existing data. The process involves data sampling. Select a subset of existing data. Long-chain model application. Apply LangChain to generate synthetic data based on the sampled subset. Model training. Combine synthetic and real data to train and validate machine learning models effectively. Example: medical billing records. Consider training a model on medical data without exposing patient records. Synthetic data creation becomes essential in maintaining privacy while enabling effective model development. Defining data model and schema. Utilize tools like Pensic to define data models and schemas. Guide the generation process using prompt templates. Creating synthetic data with LangChain. Prompt template creation. Develop concise templates to guide data generation. Customizing generation process. Specify parameters like subject, content, and desired sample size for tailored synthetic data. Generating data using OpenAI. Leverage OpenAI's data generator. Apply predefined schemas and prompts to produce synthetic data. Utilizing synthetic data for machine learning. Data conversion. Convert synthetic data into pandas data frames. Training with large language models. Augment real data with synthetic data to train model effectively. In conclusion, LangChain and OpenAI provide powerful tools for generating synthetic data, addressing challenges related to data scarcity and privacy concerns. Synthetic data is not merely a workaround, it's a strategic asset enabling robust model development while upholding data privacy and regulatory compliance. By leveraging these technologies, we can unlock new opportunities for AI development and deployment in sensitive data environments.